how to determine whether a progression is an arithmetic progression. In this video, I will show you step by step on how to solve this type of question, and we'll start right now. Hello everyone, my name is Shirley and welcome to my channel. If this is your first time here and you would like to improve in your math skills, start now by subscribing and clicking the bell so that you don't miss out anything. Let's take a look at the first question. For question 1, the 5 consecutive terms of a progression are m, n, 652, 636 and 620. A. Determine whether the progression is an arithmetic progression, AP, and B. Find the values of m and n. Okay, let's list down the progression, which is m, n, 652, 636 and 620. So this is going to be T1, T2, T3, T4 and T5. Okay, to solve A, determine whether the progression is an AP or not, we use the common difference method. So we use T5 minus T4 and T4 minus T3. If the two common differences are the same, therefore it is an AP. So T5 minus T4 is 620 minus 636 and is equals to negative 16. T4 minus T3 will be 636 minus 652, which is also negative 16. Therefore, the progression is an AP. To solve B, find the values of m and n. So, to find n, we use 652 minus d. So n equals to 652 minus d. So equals 652 minus negative 16. So 652 plus 16, you'll get 668. To find m, we're going to use n minus d. So n minus d. So n that we gotten just now, 668, minus d. So it will be 668 plus 16. So equals 684. So this is the answer. For question 2, given P, 68, 79, 90 and Q are 5 consecutive terms of a progression. A. Determine whether the progression is an arithmetic progression, AP, and B. Find the values of P and Q. So first of all, we write down the progression given, which is P, 68, 79, 90 and Q. So this is T1, T2, T3, T4 and T5. To determine whether the progression is an AP or not, we use the common difference method. So we find T3 minus T2 and T4 minus T3. So if you get these two answers the same, therefore it's proven that it's an AP. So T3 minus T2 will be 79 minus 68 equals to 11. Okay, and T4 minus T3 is 90 minus 79 is also 11. Therefore, it's proven that the progression is an AP. Okay, to solve B, find the values of P and Q. So to find P, we're going to use 68 minus D. So P equals to 68 minus D. So it'll be 68 minus 11, which is 57. To find Q, we're going to use 90 plus D. So 90 plus 11, which is 101. Okay, so this is the answer. For question 3, the 6 consecutive terms of a progression are negative 30, x, y, negative 39, negative 42, and negative 45. A. Determine whether the progression is an arithmetic progression, AP, and B. Find the values of x and y. So first of all, we write down the progression given, which is negative 30, x, y, negative 39, negative 42, and negative 45. So this is T1, T2, T3, T4, T5, and T6. So to determine whether it's an arithmetic progression or not, we use the common difference method. So I'm going to use T5 minus T4 and T6 minus T5. The two of the answers are the same, therefore it's proven that the progression is an AP. So let's solve this. T5 minus T4 will be negative 42 minus negative 39. So equals negative 42 plus 39 is negative 3. Okay, let's solve this. T6 minus T5 is negative 45 minus negative 42 equals negative 3. So since the common difference is the same, therefore the progression is an AP. So therefore the progression is an AP. Okay, to solve B, find the values of x and y. So to find x, I'm going to use T1 plus with D. So since the D is negative 3, okay, so x is negative 30 plus with the D, so equals to negative 30 minus 3 is negative 33. To find y, so y is here, I'm going to use negative 39 minus D. So negative 39 minus D, which is negative 39 plus 3, which is negative 36. So this is the answer. Do you wish to see more videos like this? Let me know in the comments below. If you find this video useful, hit that like button and don't forget to subscribe to my new videos every single week. Thanks so much for watching and I'll see you in the next video. Bye guys!